not have heard of Antarctic bottom water, but trust me, it's important. It's equivalent to the deep sea circulatory system, supplying oxygen and nutrient-rich waters to the world's oceans. But we've just realised that things are changing, and we're still unsure what these mean for the ocean, but also for our climate. So what is Antarctic bottom water? Well, it's the densest water mass of all oceans, and as its name suggests, it's found at the very deepest part of the oceans, down below 4 kilometres. Because it's super salty and cold water, it's dense, and it slowly oozes across the bottom of the world's ocean basins. It's rich in oxygen, carbon and nutrients relative to other oceans, so it replenishes our deep seas. But how does it work? Well, let's start at the beginning, but please stay with me here. So salty water doesn't like to freeze easily. That's why people throw salt on the roads to de-ice them. Where freshwater freezes at about 0 degrees Celsius, seawater freezes at much lower temperature. But when ice crystals form in seawater, salt is ejected, leaving it trapped within the icy crystalline matrix, so that droplets of super salty water, called brine, are trapped inside. Those salty droplets require even lower temperatures to freeze, so the briny water remains liquid. It's held prisoner in the ice, but only for a time. As more ice forms, more briny water is produced until channels of cold water run through the ice. And algae and tiny creatures love to live inside those brine channels. But as the ice shifts and cracks, so that super cold briny water can escape from the ice. But because the briny water is cold and salty, it's heavier than water at the sea's surface. So the briny water sinks, taking with it oxygen, carbon and important trace nutrients from the surface waters deep down onto the ocean floor. Now the ocean's like a layer cake. Different layers of water have different salinity and temperature. Because Antarctic bottom water is cold and salty, it's trapped at the very bottom under fresher and warmer layers of water that sit above. Now this is where it gets interesting. This circulatory system or pumping part comes in. Near the coasts of Antarctica during winter, the ice forms like a sheet of broken concrete, and in some areas you can even land a plane on it. But this icy blanket has amazing insulating qualities. As the ice thickens and grows as a sheet, the water below is protected from the freezing polar air above. This slows the production of new ice. But in some Antarctic areas, there are strong offshore winds that push the newly formed ice out to sea. These open water areas, called Polynyas, are important, particularly in winter. Wildlife use them as refuge during the winter time, but these areas are where this deep ocean pump starts. Because there's always open water, new ice can keep forming and so producing dense, cold, salty water that sinks to the ocean floor. And because the ocean floor around Antarctica slopes away to deeper water, this heavy, salty, nutrient-rich water slides down the Antarctic shelf, shooting, well, oozing, north along the bottom of the world's ocean basins. Now remember, the changes I mentioned before? Well, between 2007 and 2016, the Antarctic bottom water freshened. It's becoming less salty, and so slowing our deep ocean pump. So what, you might say? Well, remember, this is how the deep oceans are replenished with oxygen and nutrients. And did you know that the oxygen levels in our oceans have declined by 2% over the past 5 decades already? Less oxygen will affect ocean nutrient cycles and marine habitats. It's potentially detrimental to fisheries and coastal economies. Now, some of this will be because the warmer waters at the ocean's surface is less soluble to oxygen. But the slowing of our oceanic pump means that the deep oceans are not getting as quickly replenished with oxygen. Less salty water means that that powerful downward pumping of heavier salty water slows, even stops. If it stops, it will alter our ocean's circulation. The deep seawater will become stagnant. That can't be good.